All right, quiz number 2, study guide. Problem number 1, we've got a proportion. So we're going to crisscross multiply. And our x minus 8 times 4 is 4 times x minus 8. And it's equal to 5 times 2, which is 10. So you got to do the distributive property here. 4 times x is 4x. And 4 times negative 8 is negative 32, equal to 10. And then add 32 to each side. So 4x is equal to 42. Then divide each side by 4. And 10.5. In problem number 2, you're told that the figures are similar. What is x, meaning what is the value of x? So we're going to write a proportion. And I'm going to take 8 and put it over the x. So left side over left side. 8 over x is equal to bottom over bottom, which is 7 over 3. Crisscross multiply, so 7 times x is 7x. 8 times 3 is 24. And divide both sides by 7. So 3.4. Same with problem number 3. The figures are similar. We need to find the value of this x right here. So in this triangle, I'm going to take diagonal on the left, which is 16. I'm going to put it over the diagonal on the right, which is 25. Set it equal to the bottom of the triangle on the left, which is the x, over the bottom of the triangle on the right, which is the 9. So crisscross multiply, 25 times x is 25x, equal to 16 times 9, which is 144. Divide both sides by 25. And x is equal to 5.76. So 5.76. All right, problem number 4, use the scale and map measurements to find the actual distance from New Wilmington to Sharon through the specified town. So we've got this group of triangles here. Here's our scale. 1 inch is equal to 12 miles. What is the actual distance from New Wilmington, which is right here, New Wilmington to Sharon through Mercer? So we're going right here, this route. So what I'm going to do is our scale is inches to miles. So our scale is 1 inch equals 12 miles. So 1 to 12 is equal to, we're going to combine this 1.5 and 1.75. and we get 3.25 inches. And we're going to put that over a variable, and in this case, I'm going to use miles, or m for miles. So we set our scale as a fraction. We set it equal to the number of inches in the drawing over a variable. And the variable is what we're going to solve for. So 1 times m is m, and 12 times 3.25 is 39. All right, so the actual distance, 39 miles. In problem number 5, what is the actual distance from New Wilmington to Sharon? Again, but this time we're going through Volant. So we're still starting here, but now we're going this route. Volant, and then we're going up to Sharon. So now we're going to add together the 1.75 and the 2.25 for our proportion. So we can take 1 over 12 again, set it equal to 1.75 plus 2.25 is 4 over our amount of miles. So crisscross multiply, 1 times m is m, 12 times 4 is 48, so 48 miles. Problem number 6. 2 rectangles are similar. One has a length of 10 and a width of 8. The other has a width of 7. Find the length of the second triangle. All right, if the triangles are similar and we're talking about length and width, I'm going to set it up as length over width. One has a length of 10 and a width of 8. So 10 over 8 equal to. The other has a width of 7. So be careful here. The width goes in the denominator. So this 7 goes in the denominator. And find the length. So we're going to put an L up here. So our 8 times L, when we crisscross multiply, we're going to get 8L equals 70. Divide each side by 8. And L is equal to 70 divided by 8. 8.75. And round to the nearest tenth if necessary. So this rounds to the nearest tenth, 8.6. Say again? Oh, 8.8, I'm sorry. Yeah. Thank you. All right, number 7, a model is made of a car. The car is 10 feet long, model is 9 inches long. So car to model. Car to model, 10 feet long and 9 inches long. Look, we got 2 different units of measure. All right, so we have to, what is the ratio of the length of the car to the length of the model? All right, so since all we're going to be doing is simplifying a ratio, we're going to put these 2 unit measures in the same unit measure. So this, we're going to convert this 10 feet to inches. All right. So to convert 10 feet to inches, we're going to take 10 and multiply it by 12, and we get 120 inches. So now the car is 120 inches long, and the model is 9 inches long. So we're going to take 120 over 9, and we're going to simplify it. First thing I would do is see if the 9 goes into the 120 evenly. It does not. So we're looking for something now that goes into both of these evenly. And the only other factor of 9 is 3. So let's take the numerator divided by 3. So 120 divided by 3 is 40. And 9 divided by 3 is 3. So what is the ratio of the length of the car to the model? That's 40 to 3. Can also be written this way. 40 to 3. When they're asking for ratio of the length of car to model, whatever's listed first goes in the numerator, or whatever's listed first goes first if you're listing horizontally. All right, problem number 8 is another repeat from last week, but a lot of people didn't get this one right, so we're gonna do it again. Ratio of length to width in a rectangle is 3 to 1. So remember we had this rectangle. Bad rectangle, but anyway. Length to width, 3 to 1. We're talking about perimeter, so it's the sum of all the sides. So we've got a 3 down here, and we've got a 1 right here. And we need to solve for a multiplier, so we just put an x after everything. So now, 1x plus 3x plus 1x plus 3x, we get 8x. That's equal to 128. Divide both sides by 8. And we get an x that's equal to 16. Again, 16 is our multiplier. What is the length of the rectangle? The length is the 3 times the multiplier. So the length is equal to 3 times the 16. And that's 48. All right, so put a note, maybe star the rectangle problem when you're watching the video or you're doing practice problems watching the video. This rectangle problem, you got to make sure that you include all of the sides when you're writing your equation that's equal to the given perimeter. Problem number 9, the measure of two complementary angles. Complementary angles, they sum 90. And the ratio is 1 to 4. What are the degree measures of the two angles? We take a 1x plus a 4x, we set it equal to 90. The x represents our multiplier. So 5x is equal to 90. We then divide both sides by 5. And our x is equal to 18. 18 is our multiplier. So one of the angles, what are the degree measures of the two angles? We can go like angle 1 is equal to 1 times 18, which is 18. And angle 2 is equal to 4 times 18. And 4 times 18 is 72. All right, and a simple check when you're done is if the two angles are complementary and they need to sum 90, just add your two angles together when you're finished. 72 plus 18 is 90. So these are good measurements. Problem number 10. What is the solution of each proportion? All right, in problem number 10, we got to crisscross multiply. So we got 3n times n minus 5, and it's equal to n minus 6 times 3n plus 1. Distributive property on the left, 3n times n is 3n squared, and 3n times negative 5 is negative 15n. You got a binomial times a binomial on the right, so you have to do the distributive property twice. N times 3n is 3n squared. N times 1 is positive n. Negative 6 times 3n is negative 18n. And negative 6 times 1 is negative 6. So if we've got a 3n squared, a positive 3n squared on each side, instead of subtracting 3n squared from each side, just cancel them out. That's what's going to happen anyway. Now on the right-hand side, you got to combine like terms. Your next step is to combine like terms. So we get negative 15n equal to 1n minus 18n. That's negative 17n minus 6. So then we add 17n to each side. And 2n equals negative 6. So if we divide each side by 2, then our n is equal to negative 6 divided by 2 is negative 3. And problem number 11 should look familiar. We've got a over b equals 8 over 15. What ratio completes the equivalent proportion? All right, so if we cross multiply here, crisscross multiply this original fraction, this original proportion, a times 15 is 15a. And it's equal to 8 times b, which is 8b. So if this proportion crisscross multiplies to 15a equals 8b, and we need something equivalent, well, then the second proportion has to multiply to 15a equals 8b, right? They're equivalent, which means they're the same. So if we need a 15a, well, the a has to get multiplied by a 15. And the b, to get 8b, the 8 needs to get multiplied by the b. So this b over 15 is what completes the proportion. Crisscross multiply the first proportion and find out what your two products are. And then make sure you have the same two products in the equivalent proportion. All right, number 12. Are the polygons similar? If they are, write a similarity statement and give the scale factor. So, looking at this shape on the left, we've got opposite sides that are congruent. All right? So if these opposite sides are congruent to each other, then these opposite angles are congruent to each other. Okay, so this angle C down here is 120. And if these opposite sides are congruent and opposite angles are congruent, it makes this thing a rhombus, all right, or a parallelogram. And in a parallelogram, opposite angles are congruent and consecutive angles are supplementary. That makes angle B up here 80 degrees. And it makes angle D 80 degrees. So, look at the shape on the right. we have opposite sides that are congruent. And if these opposite sides are congruent and one of the angles is 120, well, if angle M is 120, angle K is 120, angle N is going to be 80, and angle L is going to be 80. So your first rule of similarity is that corresponding angles are congruent. It meets that criteria. The second criteria is that corresponding sides are proportional. So what I'm going to do is I'm going to take one of the shorter sides on the left. All right? I'm going to use the ratio short side to long side. Short to long. I'm going to take a short side on the left, which is 9. I'm going to put it over a long side on the left, which is 21.6. I'm going to see if it's equal to a short side on the right-hand shape, which is 1.8, over a long side on the right-hand side, which is 4.68. If I crisscross multiply and the products are the same, then the shapes are similar. If I crisscross multiply and the products are not the same, well, then the shapes are not similar. So I'm going to take the 9 times 4.68 equals 42.12. And we're going to see if it's equal to 21.6 times 1.8. And that's 38.88. These aren't equal. If the crisscross products are not equal, then the shapes are not similar. All right, so are the polygons similar? That's just a no. If you had to explain it, you could say no. Corresponding sides are not proportional. Number 13, the polygons are similar, but not necessarily drawn to scale. Find the value of x. All right, so they're similar. So we're going to write a proportion. I'm going to take from the shape on the left, I'm going to take 6 and put it over 3. I'm going to set it equal to, if I did 6 over 3, I basically did left side over right side, has to equal left side over right side. So 59 over x. All right, in this case, it's you can see with your eyes which sides correspond to which sides. All right, if one of these shapes was rotated or flipped, then you would have to be given a similarity statement so that you could use corresponding sides from the description. So 6 times x is 6x, and 3 times 59 is 177. Divide both sides by 6, and our x is equal 29.5. All right, problem 14. In a diagram of a landscaping plan, the scale is 1 centimeter equals 10 feet. Centimeters to feet. 1 to 10. Centimeters to feet. 1 to 10 equals, in the diagram, trees are 4.2 centimeters apart. So our 4.2 goes in the numerator. How far apart should the actual trees be planted? Well, we're going to solve for how many feet apart they should be planted, so I'm going to use an F. All right, centimeters to feet. 1 to 10 equals the 4.2 centimeters that you get from the drawing, and we're going to find the actual feet. So 1 times F is F, and 4.2 times 10 is 42. And problem number 15, in a scale drawing of the solar system, the scale is 1 millimeter to 500 kilometers. So we got millimeters to kilometers is equal to 1 to 500. For a planet with a diameter of 5,000 kilometers, if we're millimeters to kilometers, 1 to 500, what should the diameter of the drawing be? The drawing is going to be smaller, so we're going to solve for millimeters over 5,000. We're going to crisscross multiply again, so 500 millimeters is equal to 5,000. Divide each side by 500. And our millimeters equal to, we can, anytime we've got all these zeros, we can simply cancel zeros. And 50 divided by 5 is equal to 10. So in the drawing, we need to be 10 millimeters apart. All right, and that completes your study guide for quiz 2. So for the rest of the period, you can get a computer, you can open the video and do practice problems as we have discussed in the past, or you can get your electronic assignment finished because it is due today.